Hello, everyone. It's indeed inspiring to see you back again. So we were discussing handling missing values with PySpark in the last tutorial, and now we are in the sixth tutorial. And here, let me just quickly take you through what we did in the last one, and then we will continue with the fill method. Okay, so let me just execute. So first statement is importing the Spark session. Second statement is creating the object of Spark session. Third statement is loading the iris data set and creating a data frame, a PySpark data frame. And here we can see the 20 records of it. Iris dot columns will show us the columns of the data frame. And I wanted these columns to be renamed, and therefore I have written this command to rename the columns. And after that, again, we will just check whether the column names have been changed or not. Iris.print schema, this gives us Yes, so iris.print schema, this gives us the schema of this gives us the schema basically of all the columns. So here you can see that sepal length, petal weight, so all are string over here. And then we did na.drop function. So this shows that all the na values or the null values have been dropped. As I told you, this is just displaying after dropping it. It is not storing it into the original data frame, that is iris. So we can see that they are dropped, but they are not, the iris data set is not getting changed. It is as it is, okay, as it was in original form. Now here we have different strategies. Drop, you can see the last video if you want to check the uh, functionality of all of them. Yes, so now let's come to the exact part what we actually need to do. So here we need to go with the understand the fill method. So fill method is, this is basically imputation. Imputation means that if you have NA values, okay, or you have null values, so how you can replace them. So let us start with very simplest form of the fill method. So iris is the data frame I have. So iris dot NA dot fill method we'll be using. And here I'll be just putting some value. So for example, now the values, if you see here, they are shown as null. And if I want to represent them with some other string, so let's say some string like missing. So I can just put missing over here and type the show function ahead of it. And you can see wherever we have null or NA values, they are replaced by missing values. So this is useful if you have same format of data and you have some default value or some standard value to be substituted. Then basically you can just use iris.na.fill and you can just pass whatever you want to fill in. You may fill some numeric value as well. But now here you can see that this column is actually string, and rest of the columns, we saw that the columns are actually string, but they can be converted into float because the values are float here. So there should be a different way of imputing the values or replacing the missing values. There needs to be a different way. So how can we do that? Let us explore that. So we can do that by selecting a specific column. For example, if I just select a specific column, let's say the data is very small in my case. So if I just see that this is iris setosa, this is iris setosa, I also want to put the missing values as setosa, iris setosa. So let me take this value and I'll just put iris setosa for this particular column. Okay, so here I'll be writing iris.na.fill, and inside this I'll be writing the iris setosa, and then I can just write show. And here you can see that just, oh, I'm sorry, I did not do any kind of changes here. So let me introduce you the changes over here. So here you can see that we can fill a subset. Okay, so I'll be putting a subset over here. And how will I do that? I'll just pass one more parameter, and here I will put it as class, because that is the last column and that is class. Okay, now let me enter and execute it. So you can see that all other columns, they have null as it is. The nulls have not been changed, but for the class the value has been iris setosa. Okay, so this is something I did because I was aware that only the missing values present, they are in iris setosa, and the other ones, they are not having iris setosa, they are not having missing values. Okay, so therefore this function worked for me. And now if you want to use different strategy for each column, you can do that. By this way you can do that. You can just pick up a column. Let's say I want to use for these four columns, I want to use some single value. So for that purpose, what I can do, so here I'll just write iris dot columns. So if I write iris dot columns over here, and inside that you can see these are the columns we have. So I'll be imputing you using these columns, iris.na dot I have to write fill method, and inside it I have to write some value. So let's say I just want to put 3.5 value for all of them. Let's say that's some standard I've got. So I'll be putting up this particular list, okay, except the class one inside it, and I'll be putting that into a list. And now you can see that what difference it is making, what way it is basically imputing the values. You can see that all the nulls have been imputed, but now this particular class column has been left as it is. Okay, so I told you that this iris.na is not making any changes in the original data frame. If you want to, you can just write iris is equal to iris.na.fill. Okay, so you can just reinitialize the iris. So I'm not doing that. I'm just demonstrating that how does it work. If you require, you can do that part. Now moving further, I have one imputer function, that is something new. Okay, so I have one imputer function which is coming from PySpark.ml.feature. So let me introduce you with that also, because this is something I'm manually putting up the values. So if you want a function, okay, to be directly used, and that should substitute the value, so we can do that as well. So let me introduce you with that. So we need to import from PySpark.ml.feature. So let it get auto completed. It's not getting, yeah, it's getting. So yes, so from PySpark.ml.feature, I can import imputer, imputer, imputer. Okay, so this imputer is going to help me out. Now let me tell you, I'll be creating an object of this imputer. So imputer is equal to imputer. Yeah, so this object I'm creating, and now I need to pass certain parameters into it. And what are these parameters? So I have to pass input columns, so multiple columns I'm going to pass here. Okay, and I'm going to pass the output columns as well. So input columns, again I'll be just picking up this particular list. Okay, so the whole list I'm picking up and I'm putting it here into input columns. Okay, so here if I want, I can drop this one because I'll be using strategy as mean, so mean value will get imputed. So I'm just removing that class one. Okay, and here I need to put comma, and now I just want to get the output columns list here. So in case of output columns, what I can do, I can give them a name. Okay, some name I can give them. So how I can give them? By string formatting, I can give them some name. So here, the whole string will be coming, and dot, I can just write imputed. Okay, so this will basically help us. Underscore imputed will be added. So sepal length, okay, sepal underscore length underscore imputed. So this will tell us that that is the imputed value. Okay, so after this, I can just yeah, complete this dot format, and it will just add up that the C for all the C's which are present in the list which I have copied. Okay, I just need to remove this one, this class one I can remove. Okay, let me just check with the braces. So I believe, yeah, one brace is extra over here. So let me just, yes, remove that brace. So all the braces are matching now. Okay, fine. So this is the imputer object I'm creating with the help of imputer class. And here I need to mention the strategy. So set strategy function I'll be using. You can see that this is set strategy function, and I'll be using mean, MEAN, mean function. Let me execute this. So imputer object is created, right? So this imputer object I can use by like this imputer.fit. Inside it, I can put my data set, which is iris, and I'm putting this data set iris. And after that, what I will do, dot transform. So this transform, so fitting means imputer will be learning from the data. Transform means it will be generating or converting and generating the new columns which I'm expecting. Okay, so transform, there also I'll be putting iris, and at the end I'll be adding up in the pipeline the show function, and it is giving illegal argument exception. So let us read what is the exception. Okay, so it is telling that sepal length must be of type numeric, but it was yeah. So we saw that this is there, that all the columns it has taken, they are in the form of string. So let us before applying this particular function, let us do one more thing. Let's convert. We can convert all the columns with the like we can typecast the data type. Okay, so iris is equal to iris dot with column. And here we can just pass the particular column name, and we can just change or cast its data type. So first one is sepal length, sepal length, sepal length, and we'll be typecasting. So sepal length, what we will do here, we will be doing iris. Just a second, yeah. So I should do iris, okay, of sepal length, sepal length, okay. So this we will be typecasting it to float, okay. So we'll be typecasting it to float. So let me just do that. Dot cast function we will use, cast, and here we will pass float. So you can see that I'm typecasting it to float just to test the first one. Okay, let me just check now. Iris dot print schema. So print schema is going to give me, yeah, so it has become float. So let me just continue with this, and for all of the other columns I'll be doing this part. So let me just copy this for the second one, for the third one, and for the fourth one I need to do. Fifth one I'll not be converting because it is a string value. I need not to convert it into the float value. So sepal width is the other one. Then we have petal length. So let me just change it to petal length, petal petal length. This one is petal width. So let me change it, petal petal underscore width, petal width. Okay, so I have converted it, and inside also I'll have to write the name. So sepal width here also I should mention, petal length here also I should mention, and this one I should mention here as well. Okay, so this is what I did, and let me just execute this. And somewhere some issue I'm facing. And what is the issue? Let us check. It is saying unexpected end of file parsing. For which one? For petal width, it is saying. Okay, so petal width. Okay, so I need to remove this. I didn't do that. It is executed, and here you can see that we have float, 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 and float. Okay, and the last one, class one, is string, and let it be string only. Here also, what we can do, I can, let me just execute this, and I'm expecting that it is be giving an error for the class because it is string. So I can remove that one. Is it giving that? No, no. Oh, yeah. So let us not remember, forget that. We just pass sepal length, sepal width, petal length, and petal width. So it is not considering the class column. So that is fair enough. And we are getting the imputed values, and the strategy used is mean. You can see here the strategy used is mean. So it is getting the mean value out of that particular column and substituting it at the place of NAs. So here you can see that this is 0th row, first row, and second row. So in the second row, if I show you, we have a null over here, second row, and petal width imputed. So look at petal width imputed. So petal width imputed. So it has got 1.21 as the mean value substituted. Okay, so this is how I can get the values imputed, and later on I can drop off the original columns because I have got the imputed values. That is something I can do. So this was all about how you can handle the missing values and impute them or replace them with the help of fill method and the imputer function. Hope you enjoyed this. Keep watching. Thanks a lot.